بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Section 2.4 Trigonometric Limits. The aim of this section to discuss limits involving trigonometric functions and introduce the squeeze theorem and its applications. And here we mean by trigonometric that sine, cosine, tan and its inverse. So first we will discuss limit involving trigonometric function, then we will introduce the squeeze theorem and see an application for this theorem. So we have an example 1. Evaluate A. Limit sine x when x approach to pi. B. Limit of cosine x when x approach to pi. So for sine and cosine and tan and all the trigonometric function, if you want to find limit, just replacing x by whatever the value here. So limit of sine x when x approach to pi, this is same as sine pi, which is equal 0. Similarly, limit of cosine x when x approach to pi, this is cosine pi, which is equal 1. So just replace x, but whatever value here you will get, it will be, this is the limit of your function. Here we have an example to evaluate limit of sine 1 over x when x approach to 0. So this will be equal, we need to replace this x by 0, so we'll get sine 1 over 0, and we know that 1 over 0 does not exist, so we conclude that limit of sine 1 over x when x approach to 0 does not exist. So theorem 241, which is squeeze theorem. Suppose f, g and h are functions for which f of x is between gx and hx for all x in an open interval that contains a number a, except possibly at a itself. So may our function is not defined at a. So if limit of gx when x approach to a is equal L, and limit of fh when x approach to a is equal L, then we conclude that limit of fx when x approach to a also equal L. So if your function f, g, h is as a following, where fx is between gx and hx for any value in the interval, and you have that limit of gx when x approach to a is equal L, so the limit of this one is equal L, and limit of this function, which is h of x when x approach to a, also equal to L, then you conclude that limit of fx also is equal to L when x approach to a. يعني هذا السكويز ثيرم تقولنا إنه إذا كانت عندنا function f محصورة ما بين two functions اللي هي ال g وال h، بحيث إنه limit of ال g لما ال x approach to a تساوي L، ونفس الشيء limit مال ال h لما ال x approach to a L، بحيث إن هذا ال L نفس ال L هذه. إذا نحن على طول نقول إنه الليمت اللي الدالة ال f اللي هي محصورة ما بين ال g وال h لما ال x approach to a limit نفس الشيء يساوي L، and we call this one squeeze theorem. So here this is an example of the application of squeeze theorem. Find the limit of x squared sine 1 over x when x approach to 0. Here you cannot distribute the limit, because if you distribute the limit of x squared will be exist, but limit of sine 1 over x it is not exist, because we find here limit of sine 1 over x when x approach to 0, we said it is not exist. So we cannot distribute the limit, and we cannot say it is equal limit of x squared multiplied by limit of sine 1 over x. So here we will use some technique to find the limit, and then we will use the squeeze theorem. We know that for the sine x and cosine x it is always between -1 and 1. For any value you substitute in sine x or cosine x, you will find the result always will be between -1 and 1. And we will see now how to rewrite this function x squared sine 1 over x using the information that sine x is between -1 and 1. So we'll start here by writing that sine 1 over x is between -1 and 1. But here our function, it is not sine 1 over x, it is x squared multiplied by sine 1 over x. So we'll try to rewrite this function to be similar like this function in the question. So we need to multiply our function by x squared. So here I will rewrite the function again. Then we have here sine 1 over x less than or equal. So since our function is multiplied by x squared, so we need to multiply our function also by x squared. So multiply this one by x squared, multiply this one by x squared, and multiply this one by x squared. So now we will have minus x squared is less than or equal x squared sine 1 over x less than or equal x squared. So now by squeeze theorem we will find limit of this function and we will find limit of this function. Since here it is said limit when x approach to 0, so we need to evaluate limit of minus x squared when x approach to 0. And remember here, since the question said x approach to 0, so you need to write here x approach to 0 only, without from left, without from right. So when x approach to 0, here it is equal 0. Similarly for this one, limit of x squared when x approach to 0, because the question said when x approach to 0, so we'll take when x approach to 0. So this one is a polynomial, the limit is equal 0. So now since the limit of this one is equal 0, limit of this one also equal to 0, so by squeeze theorem, we'll say it by squeeze theorem, then we conclude that limit of x squared sine 1 over x when x approach to 0, it is equal to 0. So after writing our function as the original question, so we have x squared sine 1 over x is between minus x squared and x squared. We'll find the limit of minus x squared, so we'll find the limit of this one, and we find the limit of this one when x approach to 0. We find it is equal to 0, both of them. So according to the squeeze theorem, we conclude this one is the limit of x squared sine 1 over x when x approach to 0 is also equal to 0. يعني هنا بنستخدم الخاصية إنه الساين والكوزاين بتوين السالب 1 والواحد. بعدين بنحاول أول شي بناخذ الساين 1 over x اللي هي بتوين minus 1 وال1. بنحاول نحول الفانكشن هذه إلى الفانكشن اللي معطلنا إياها في السؤال. يعني إحنا ابتدينا من ساين 1 over x. نحاول نكتب الفانكشن اللي هي ساين 1 over x لما تكون بتوين minus 1 ل1، نحاول نكتبها بصيغة الإكس سكوير مضروبة في ساين 1 over x. فاللي ناقص اللي هي كانت minus 1 1، إذا بنضرب هنا في x سكوير نضرب في x سكوير نضرب في x سكوير. إذا صارت عندنا نفس الفانكشن الأصلية في السؤال. الحين نقدر نجيب الليمت. طبعا على أي أساس نجيب الليمت؟ نفس السؤال، إذا x approach to 0 نجيب x approach to 0. إذا في السؤال مكتوب x approach to 0 from left، إذا نجيب x approach to 0 from left، x approach to 0 from left. إذا السؤال جايب x approach to 0 from right، إذا نكتب هذا x approach to 0 from right ونجيب الليمت هذا x approach to 0 from right على حسب السؤال. طبعا هنا x approach to 0، إذا هذه بتكون 0 وهذه 0، إذا by squeeze theorem الليمت مال اللي هي fx بيساوي 0. And here we have another example, which is find the limit of root x multiplied by 1 plus cosine square 2 pi over x when x approach to 0 from right. Here also you cannot distribute the limit because limit of this one does not exist. So we will use that the properties that cosine is between minus 1 and 1. So here we have the solution. Our function is, remember this one, root x multiplied by 1 plus cosine square 2 pi over x. So we know that the cosine function, so we'll take cosine 2 pi over x. So cosine 2 pi over x is between minus 1 and 1 for x not equal to 0. Because if x is equal to 0, we get here it is not defined. So now we will try to write our function as this one. Here we have cosine squared, and here we have cosine. So we need to square all these functions. So we'll square minus 1, we will square cosine square, we will square 1. So the square root of 1 will be 1, square root of cosine will be cosine squared. But square of minus 1 will give us 1. We cannot write cosine square between 1 and 1 because there are some numbers between 0 to 1. That's when you square it, you will lose it. If you write it here, it is from 1 to 1. Let us show that now. So here we have the line number, and here we have minus 1, 0, and 1. If you squared minus 1, you will get it is equal minus 1 squared, so this will be equal 1. So minus 1 squared will be 1, and we say the square root of 1 will be 1. And we have cosine. For example, here it is minus 1, and here 1, cosine x. So we said if we squared all sides, so we'll get here minus 1 squared, then cosine of x, here cosine squared, sorry, and here 1 squared, which is 1. So if you square this 1 and you say it is 1, so that's mean your cosine square will be just from 1 to 1. But here, for example, if we said from the beginning our function is between minus 1 to 1, for example, here we have minus 0.5. So minus 0.5 squared, if you square this 1, so minus 0.5 squared, you will get 0.25. So the square root of this one is equal 0.25, and if you take here 1, you will lose the point, which is the point where here you have some point. That's when you squared it from here, from the negative, you will get this value. So if you take it from 1 to 1, you will lose all this value between 0 and 1. So that's why here we start this one by writing it is from 0 to 1. يعني بالمختصر نحن عندنا قلنا الكوزاين موجودة بين السالب 1 والواحد، لكن لما جينا نربعها اللي هي الكوزاين سكوير صارت عندنا من الزيرو لحد الون. طيب ليش أخذناها من الزيرو ما أخذناها من الون لحد الون؟ لأن لو أخذناها من الون لحد الون إذا معناته إننا نحدد نقطة واحدة فقط اللي هي الواحد. طيب إيش صار على النقاط اللي موجودة هنا مثلا ماينس 0.5؟ ماينس 0.5 لما أربعها بيطلع لي اللي هي 0.25. إذا القيمة 0.25 اللي هنا اختفت. طيب اللي هي مثلا لو أخذت هنا مثلا ماينس 0.2، ماينس 0.2 لما أجي أربعها 0.4. فأنا لو أخذتها من الواحد لحد الواحد إذا معناته كل القيم اللي بتوين 0 لحد الواحد بتختفي. أساس كذا لما يكون عندي هنا ماينس 1 سكويرد واللي هي الفانكشن مثلا كوزين سكوير دايما أخذها من الزيرو لحد الون. نفس الطريقة لو كانت عندي ساين سكوير أخذها from الزيرو لحد الون. إذا كانت كوزين والساين بدون تربيع باخذها من الماينس 1 لحد الون، لكن لو كانت فيها تربيع باخذها دائما from 0 لحد الون. So here we have 1 plus cosine square, so we need to add 1 for all functions. So here we have 0 plus 1, which is 1, cosine square plus 1, so it will be 1 plus cosine square, and 1 plus 1 will be 2. Then have we finished? Not yet. We need to multiply it by root of x. So here I multiply 1 by root of x, it will be root of x. 1 plus cosine square multiplied by root of x will be root of x multiplied by 1 plus cosine square. And here we have 2 multiplied by root of x will be 2 root of x. Now if I compare this one, root x multiplied by 1 plus cosine square, here I have root x multiplied by 1 plus cosine square. So now I reach to this function. I need to find the limit of root x and the limit of 2 root x. The limit when x approach to 0 from right. So I will take limit of root of x when x approach to 0 from right, and limit of 2 root of x when x approach to 0 from right. We know that we find this one in the section 2.1, it is equal to 0. And similarly for this one, limit of 2 root x when x approach to 0 from right, it is equal to 0. Since the limit here is equal 0, limit here is equal 0, so by squeeze theorem we conclude that limit of root x multiplied by 1 plus cosine square 2 pi over x when x approach to 0 from right is equal 0.